students. I'm going to show you a few things that will help you with your statistical analysis for the 2020 retention project. So a couple of things I want to bring up to you is the correlation test you can do, and a few other hypotheses tests which I will show in different videos. So the first thing we're going to look at is the master survey Excel results that I've sent you out earlier. Has 4 tabs, one with words labeled. So in this one we have things like always, rarely, never. One with coded with numbers. So go to the same question. Basically we have numbers responding to the choices. One of the spreadsheets lists out the what the numbers represent. So 5 in this case represents either always or very likely or strongly agree. So in this first demonstration, we're going to look at a correlation analysis and a correlation test. What we're going to do first is we're going to hide the middle 100 rows of data. Hiding them just makes it easier to see the bottom part. You'll know we're hiding things when we're looking at there's row 3, 4, then it jumps to 107. The data is still there, it's just being hidden. So the first thing we're going to do is a correlation test. We're going to do that by looking at question 6 and question 9. If I bring up the survey, there's the master survey, which is also available to you. Question 6 asks, how often have you experienced academic struggles as a student? 5-point scale. Question 9, do you agree that it is appropriate for instructors to discuss your course progress with each other on a scale of 1 to 5 as well? So these choices have been coded numerically. So strongly agree is 5, agree 4, undecided 3, disagree 2, and strongly disagree representing value of 1, as we can see in this little part. So we're going to do our little, see what kind of correlation there is between question 6 and question 9. So what we do is we use this function. It is equals Pearson. That's a correlation value. So equals Pearson bracket array 1 comma array 2. Array 1 is just one of the sets of values. So we're going up from R3 down to R108, comma, do the same thing with question 9. And there's a correlation. We can make that a little bigger. Not a very good correlation between those two questions, 0.078 or so. One thing we want to do after you do a correlation is test to see if it is significant. One thing we can do to run this really test of significance is we go to the Data tab. So we're up here, and we have this data analysis add-on for the tool pack. Now, if you're using a college computer or access to the college's network or your own computer, you may not have this data analysis function readily available. So what you have to do is go into File, Options, Add-ins, click Go, and just make sure that first one has a check mark on it. Then click OK. And then under the Data menu, it will show up on your far right. So we're going to click this data analysis. We're going to scroll down until we get to regression. Input Y range. Technically, one of these is going to be predicting the other, but because we're looking for a correlation, does not really matter which one is Y or which one is X. So I'm going to use question 9 as the Y, question 6 is going to be the X, and you'll notice that I am including the labels, so checkmark labels on there. That just makes the data Excel output a little more easily understood. So that is all we need. So we're going to click OK. And a couple things in here we're going to look at. There is the Pearson R value. So remember in stats we had this R value. So that would be what this value equals. The only thing else we need from here is this significance of F. This is in essence the p-value for this hypothesis test. Now we can develop a really quick null hypothesis. Null hypothesis for correlation test is how should I write this? The slope is equal to 0. Remember, slope would refer to the correlation between the two variables. So the alternate hypothesis, slope is not equal to 0. For all of our hypothesis tests, we're going to use an alpha value of 0.05. The decision rule, as per that email message I sent out, is to reject the null hypotheses. If I can type. If the p-value is smaller than alpha. Notice p-value is not smaller than alpha, so our decision is to do not reject the null hypotheses. Basically, not rejecting it means that this hypothesis has not been proven incorrect. So we are left with the belief that the null or that the slope is equal to 0, which means that there is no correlation, no significant correlation between those two variables. One thing that we might want to do is use one of the variables to predict the output or outcome of the other variable. Using question 9 to predict question 6 in this case would not be correct because the relationship is not significant. So we would have to find a different question to look at. But this is how you can do one of the tests. Now what I would recommend is you go through your survey questions when you have a 5-point scale and you look at some questions that may support one of your findings or something that you feel strongly about, and use some of the data to test to see if there is a significant relationship. So in this question with 6 and 9, maybe we theorize that students that experience academic struggles would also find it appropriate or not appropriate for instructors and advisors to discuss with each other about their progress. Basically, there is no correlation between questions 6 and 9.